All right, hello students. Welcome to an empty upper school quad. Today we're going to go over the basics of Pythagoras. So these are the same notes as what's in the PowerPoint that you've been given via Connect. So just follow along with that and we'll get into it. Okay, so first thing I'd like for you to do is to draw yourself a right-angled triangle like this. So straight as you can. Put in that little square in the corner that tells you that that's where the right angle is. What I would like you to do, the side that is opposite the right angle, we're going to label that the hypotenuse. Hypotenuse is just a fancy word for the longest side in a right angle triangle. It's always the one that's opposite the right angle and it's the longest side as well. So that's how you can identify that one. What we're going to do as well, we're going to label the hypotenuse, we're going to say that that's 5 units long. The side on the left we're going to say is 3 units long, and the side on the bottom we're going to say is 4 units long. We're also going to label those sides. We're going to call the hypotenuse C, and we're going to call the other two sides A and B. Doesn't hugely matter which way around you write those, but we'll talk about that in a second. Anyway, so Pythagoras was a ancient Greek philosopher, mathematician sort of guy. He's got a lot of discoveries attributed to his name in like mathematics, music, astronomy, that kind of thing, but is most famous for coming up with Pythagoras' theorem, which is what we're going to do today. And that tells us that if we square the shorter two sides of a right-angled triangle and add them together. So in this case, a squared plus b squared. So these two shorter sides here. Square those and add them together, we'll always get the length of the hypotenuse squared for every single right-angled triangle in the history of human existence. And non-human existence, I guess. Okay, so if we take that equation, so a squared plus b squared equals c squared, what I'm going to do now is substitute in the values from the triangle that we've drawn for ourselves. So we've got, and this is just to show you that it works. So a squared, well, the side length a is 3, so I'm going to type in 3 squared. I'm going to add that to the side length b, so 4 squared. So adding those two together should give me the value of the hypotenuse squared, which for this triangle is 5 squared. So 3 squared is 9, 4 squared is 16, 5 squared is 25, 9 plus 16 is indeed 25, and 25 equals 25. So you won't always get nice square numbers like that. These are called Pythagorean triples, where they work out exactly, but it's just to show you that it indeed works. And that 3, 4, 5 is something you might use if you become a tradesman. You can say you want to make sure the corner of a door frame or a fence or whatever is square. If you start with 1 point, measure 3 centimeters or inches or whatever, measure 4 inches the other way, and if the distance between them is 5 exactly, then you know that the angle's square. So that might be something that you end up using later on. Okay, so how can we use this to solve problems? So what I'm going to do, I'm going to draw the same right angle triangle that you've got in your PowerPoint notes to help you out. So I've got a right angle triangle, draw this along with me as well. That's got a bottom side length of 8 meters, a height of 6 meters, and we don't know what the hypotenuse is, so we'll say that, we'll just call that C for now. So the steps to find the length of the missing side. So number 1, you're going to want to label the triangle. Number 2, you're going to want to write the equation itself. So write the equation and substitute values. When I say substitute values, we're going to use the values that are given in the question for this kind of thing. And then the third step is to bring it all together and solve it. Okay, so the triangle that we've got on the right hand side, so I'm going to say this side length is A, this side length is B, and as we've said already, we'll call the hypotenuse C. Okay, so writing down the equation, for Pythagoras, a squared plus b squared equals c squared. So that's part of step 2. Now I'm going to substitute in the values, which is the second part of step 2. So my side length A is 8, so it's going to become 8 squared, plus B, which is 6 squared, equals the hypotenuse squared. So we don't know what the hypotenuse is yet. That's what we're working towards. We've got to find what the missing number is. Okay, so 8 squared plus 6 squared, so 64 plus 36 is 100. So 100 equals c squared. Okay, so remember that when you've got something squared like that, it means that we don't know what the hypotenuse is yet, but whatever it is, the hypotenuse multiplied by itself gives us 100. So what I'm going to do now, I'm going to swap these round, and instead of writing c squared, I'm going to write c. So we want to find out what number multiplied by itself gives us 100. So the opposite action to that is to find out what the square root of 100 is, because that will tell us what number multiplied by itself will give us 100. The square root of 100, as you probably will know, or you can use your calculator if you really need to. The square root of that one is 10. So that's your actual answer, and we'll be mindful to use the same units as what's given in the question. So 10 meters is our actual answer for that one. Okay, we'll do the second question from the PowerPoint now. So another right angle triangle of different orientation. Still a right angle triangle, even though it's been, flipped around a little bit. So we've got 8 centimeters and 13 centimeters. I think the question says find the length of the missing side to 2 decimal places. My eraser's not working today. I have to manually select it, which is a bit annoying. Find length of missing side to 2 decimal places. Okay, so step 1, we'll start with step 1, is still the same. I'm going to label this A, B, and C. Doesn't matter which way around you call A and B, but it's as long as you pick one and stick to it. Okay, now I'll write down the equation. A squared plus B squared equals C squared. Now I'll substitute in what I know from the diagram. So side length A is 8, so 8 squared, plus B squared, so 13 squared. Is going to give us the length of the hypotenuse squared, which we don't know just yet. Okay, so the squares of 13 and 8, we add them together, that will give us 233. And that's equal to the hypotenuse squared. Then I'm going to swap it around, but write C is equal to the square root of 233. Again, it's what number multiplied by itself will give us 233. Now this one is a little different, because you're not always going to get a nice round answer. The answer for this one is 15.26 when you round it to 2 decimal places. Make sure you put your units in there as well. So 15.26 centimeters to 2 decimal places. Cool. And this is a pretty good opportunity to check that your answer makes sense as well. So don't forget that the hypotenuse is the longest side. So 15.26 centimeters should be obviously longer than 13 and 8, which it is. So that seems like a pretty sensible answer to me. Okay, now we're going to do the third example, which is a little bit different. So we've got another triangle with that upside down sort of origin. We've got 7 centimeters for that side length, 20 centimeters for the hypotenuse length, and we're finding the length of the missing side again to 2 decimal places. Find length of missing side to 2 decimal places. Okay, good one. All right, step 1, label the triangle. So this one is a little bit different because we're finding the length of one of the shorter sides. So there's a little bit of rearranging that needs to occur. I'm going to call this side A, so that's become the side that we don't know rather than the hypotenuse. I'm going to call this side B. I'll write out my equation, A squared plus B squared equals C squared. I don't know what A is yet, so I'll leave that as A squared. I know what B is, so I'll substitute 7 in there, so that'll become 7 squared. And that's equal to the length of the hypotenuse, which for this one I do know, that one is 20 squared. Okay, so again, evaluating what I know so far, 7 squared is 49, 20 squared is 400. Okay, this is where you've got to do a little bit of solving to help you out. I'm just going to point out that if you've not done equations like this for a while, we need to get the a squared on the left-hand side on its own. So we want to substitute this 49. So it's plus 49, we want to subtract 49 to get rid of it. But because we've got an equal sign, we need to make sure we're taking 49 away from both sides. It's really important. If you've got an equal sign, it means you have to ensure that there's balance between the two. So on the left-hand side, 49 take 49 just leaves you with a squared. But on the right-hand side, we now have 400 take away 49. So it's really important you apply that step. Okay, that leaves us with a is equal to the square root of 400 take 49, which would be 351. And evaluating that gives you an answer of 18.73 centimeters to 2 decimal places. And again, check that your answer makes sense. It should be less than 20, which it is. It's not like way less. It's not like it's 0.8 of a centimeter or something like crazy like that. That would still be possible. It just means that your triangle was really, super shallow or super steep. Okay, so they're both from the first lesson for the week. Jumping ahead to the second lesson, where you have to use Pythagoras to solve practical problems. So this is the example for lesson 2. We've got a fire on the 12th floor of a building. It's a bit of a macabre example, so I hope that's okay. A child needs to be rescued from a window that is 20 meters above ground level. If the rescue ladder can be placed no closer than 6 meters from the foot of the building, what is the minimum length ladder needed to make the rescue? We want to give our answer correct to the nearest meter, so there'll be a bit of rounding to do as well. Okay, so to give you an idea of what you need to actually do, highlighting the keywords in the question and any numbers that you're given is a really, really good first step. Another good idea is to draw yourself a quick diagram just to help you make sense of the situation. I don't know if I'd recommend drawing a burning building with a child to be rescued in the 12th floor, but I will draw a building, maybe with someone smiling on the 12th floor. You can't really see that. Okay, so the window is 20 meters above the ground, 20 meters. We've got a ladder we're going to use as well. And the ladder can be no closer than 6 meters from the foot of the building. So now we're looking, and we need to find what the minimum length ladder is. So we'll call that C. So the idea of this one is that if you were having the ladder closer to the building, the ladder would become shorter. But you can have it as far away as you want. It just means the ladder has to get longer to do that. And getting longer is fine, but it's asking what the minimum length ladder is. So with these Pythagoras questions, you're always looking for, well, what's my right angle triangle going to be? Because I need to use a right angle triangle to solve using Pythagoras. So I'm going to use that right angle triangle from my diagram. I'm going to redraw a neat version. I'm going to say my side length here is 20 meters. My side length here is 6 meters. I'll label it. We'll say A, B, and C. Missing side length is the hypotenuse. That's the actual, thing that we need to answer as part of the question. So again, I'm going to follow my steps. I'm writing the equation down. I'm going to substitute my values in. So 20 squared plus 6 squared equals the hypotenuse squared. I think I've pre-written this one, or will I have to get my calculator out? Oh no, I've pre-written it. Go me. Okay, so now we have 436 is the sum of those two squares added together. So again, what number multiplied by itself will give us 436? So we need to find the square root of 436 and round it to the nearest meter. Now from memory, this becomes something like 20.8 something, which when you round it to 0 decimal places should give you 20 meters. Now, as another tip, worded questions usually require a worded answer. So I'm just going to reread the question to make sure I'm answering it in the correct way. So it's the minimum length of ladder needed to make the rescue. So my actual answer is going to be the minimum length of ladder is 20 meters. So yeah, so worded questions require a worded answer, and obviously the way I've answered that matches the question that was given as well. Okay, good one. So you've got some questions to work through on that topic, 2 lessons worth, and we'll see you when we return for trigonometry in a couple of days. Bye for now.